Hi everybody, it's Mr. Helpful Not Hurtful sidekick in for him for the day. So we're going to do some volumes practice. The formula that you need to know for all of these problems is that the volume equals the area of the base times the height. So in number 1, our base is a rectangle. So our volume is the area of this rectangle, which is 10 times 18 times our height of 6. So 10 times 18 times 6 gives us 1,080, and our units are inches cubed. We call this a rectangular prism. So when we move on to number 2, this is also a prism, but it's not rectangular. This is actually a triangular prism. So you can think of a prism as an object that you can slice and make equal slices. So I'm going to think that this is a piece of cheese. So if I slice, I would get all of these little triangles of cheese. So when I'm thinking about height, that's actually 17. That's my little h over here. Now my base is going to be this triangular shape right here. So the area of a triangle is 1/2 the base of that triangle times the height of that triangle. And then we said 17 was the height of that entire object. So we have 1/2 times 8 times 15 times 17, and that gives us 1,020. And that would be feet cubed. And finally, we have our cylinder, which just is a stack of circles. That's all a cylinder is. So we're going to use the same exact formula, but this time our base is a circle. So when we find the area of the base, that's pi r squared, which in this case our radius is 5, half of the diameter. So we have pi r squared, and then the height of this object is 14. So when we multiply that out, 5 squared is 25, and 25 times 14 gives me 350 pi. And if I round that, I get 1,099.56, and those would be centimeters cubed. So those are our prisms. All 3 of these shapes come to a point at the top. The first one we call a cone, and the other 2 we call pyramids. For a cone and a pyramid, we take 1/3 of the regular volume that we just found in 1 through 3. So we take the area of the base times the height again, but we have that 1/3 relationship, which we saw the other day where we poured the beans from one shape to another with the cone and the cylinder. So if we think about enclosing this in a cylinder, the cone would take up 1/3. So same thing over here. We have 1/3, our base is a circle, so that is pi r squared, and our height is 9. So in my calculator, I'm going to multiply this all out. 1/3 times pi times 4.5 squared times 9. And that gives me 190.85 meters cubed. In number 5, my base is a square. I see that from these tick marks saying that all sides are the same. So my volume is going to be 1/3 the area of the base times the height is 36. The area of my base is a square, so that's 42 times 42. So the other day everyone was asking, well, how come there's no pi in this one? There's no circle. So we're just finding the area of the base, which is a square, so there's no pi involved. So we don't need to round this one, but it's a really big number. 21,000 168, and that would be millimeters cubed. This last one's kind of tricky. So in number 5, we said these tick marks meant they were all the same. And the same thing applies for this triangular base right here. When I look at this base that's a triangle, it's actually an equilateral triangle. When you find the area of a regular triangle like we've been doing in this unit, we take 1/2 the base times the height. 1/2 because it's half of a rectangle, and rectangles always have right angles. So when we say that the area of a triangle is 1/2 base times height, that actually only works in a right triangle, and that's not what we have over here. We have an equilateral. So I'm just gonna draw it this way because it's easier to look at. So it says these are all 7s. They're equilateral. So I need the height of this triangle. There's my height. What did I just create? A 30, 60, 90 triangle. So this length down here is half of 7, so that's 3.5. And you can do the Pythagorean theorem here, or you can use our special right triangles, the 30, 60, 90, and that would give our height a length of 3.5 times the square root of 3, and that's from the special right triangles. Another way to do it is to do the Pythagorean theorem, which is 7 squared is equal to 3.5 squared plus that height squared. And we get 6.06 for that height. No, yes, 6.06. And 3.5 square root of 3 coincidentally happens to also be 6.06. So either way you want to do it. All right, back to volume. Since this is a pyramid, the volume is 1/3 the area of the base times the height. I think we can all agree that the height is 9. So since our base is a triangle, the area is going to be 1/2 base times height. 1/2, that base is 7, and that height is our 6.06. So we need to multiply a lot of things here. 1/3 times 1/2 times 7 times 6.06 times 9. So that gives me a final answer of 63.63 inches cubed. Speaking of tricky problems, here's another one. So you are correct if you are thinking, I have never been taught how to find the area of an octagon. You are right. You've never been taught that. So I'm going to show you a pretty cool way to think about an octagon. So if I look at this square right here, and I cut off the corners, cut off a corner, cut off a corner, cut off a corner, cut off a corner, I just create an octagon. So it says that this is a regular octagon, so that means each of the sides are 10. So that's 10, that's 10, that's 10, that's 10. These diagonals are also 10. Now if I cut off equal amounts over here and over here, then I create 45, 45, 90 triangles. If I put all 4 of those triangles together, I actually get a square with length 10. If all the diagonals are on the outside, it actually looks like this. And these are all 10. So what I need to do is find the area of this square and then subtract off 100. I'm getting 100 because all 4 of these together make a square that's 10 by 10, and that area is 100. So if I find the area of the square and then subtract, I'll get the area of the octagon. So to find the area of the square, I need to know the total length. It's not 10. From my special right triangles, These are 45, 45, 90. So to get from hypotenuse to leg, I'm going to divide by the square root of 2. And if I put 10 divided by the square root of 2 in my calculator, it's going to rationalize it for me. And that gives me 10 square root of 2 over 2, which is actually just 5 square root of 2. So each one of these is 5 square root of 2. So the total length is 10 plus 5 square root of 2 plus 5 square root of 2, which is 10 square root of 2. Since this is a square, the length and the width are the exact same thing. So the blue part right here is the area of the square, and this red part right here, 100, is the area of these 4 corners that I'm cutting off. So now it's time to put this into my calculator. (10 plus 10 square root of 2 squared minus 100. Make sure you have those parentheses in there. And I get 482.84 feet squared. Almost done. That was the hard part. So this building is made up of an octagonal prism and then an octagonal pyramid on top. So I'm going to find the volume of the prism, and then I'm going to add it to the volume of the pyramid for a total volume. So back up to the top, what we said was we always have the volume as the area of the base times the height. Well, I have the area of the base right here. So to find the volume of this part right here, all I need to do is multiply the area times 8. So the volume of my prism is 482.84 times 8. To get the volume of the pyramid, I just take 1/3 of the volume of the prism. So I'm going to add that to 1/3 of 482.84. But not times 8 this time, because the volume of this roof, the height of this roof is 11. So I'm just going to add those two things together. 482.84 times 8 added to 1/3 482.84 times 11. And I get a total volume of 5,633.13 feet cubed. All right, see video 2 for the rest of the problems.